regular expressions. If you've heard one thing in your life about regular expressions, there's a pretty good chance that it's this quote, which is a little hurtful and pessimistic. Regular expressions do have a somewhat bad reputation because they are this really great hammer that make everything look like a nail, including screws and light bulbs and kittens. But, you know, sometimes you really do have a nail, and it's totally okay to hit it with a hammer, so I think it's a little unfair to discard this tool entirely. What are regular expressions? They're essentially a mini language that you can use to detect patterns in text. If you have some kind of body of text and you want to find certain substrings and sequences of characters, oh look, there's a thing that I can look at, which is right here, that's awesome. Yeah, so you can use them to search for substrings or do search and replace, and split strings according to some kind of delimiter. And you may have, if you use the Unix command line, you've probably encountered grep, which is for searching, set and org, which can sort of, they're kind of like line editors that you can use on text files. And a lot of text editors have some kind of regular expression mode in the search and replace dialog, sometimes hidden away somewhere where only like massive nerds can find them. And regular expressions are not specific to any single programming language. Most programming languages have some kind of implementation. Sometimes they're built right into the language syntax. Sometimes they're in built-in libraries. Sometimes you have to like load an external library. But basically, if you've learned them once, you can use them anywhere. There are some minor differences in the syntax implementations, but there are basically some standards. And sometimes you need to like escape or not escape different characters. And you can usually switch modes. So basically, it's like pretty universal once you've learned them in one place. Why would you want to use regular expressions in Python in the first place? We have string methods. We have find and replace and split, and we can use all these things on text. But these are relatively simple methods which are mostly designed for fixed patterns. So if you know that you're always going to be looking for sh, or you're always going to be using dogs and cats, or you have like a perfectly predictable string where the delimiter is always going to be a comma or a space or something, then you don't need regular expressions. You can just use the built-in methods, which are perfectly fine. The problem is, what happens when this isn't a constant string pattern? What happens if you want to find anything that starts with a certain letter, or starts with some letter and ends with another one, or every three-letter word, or stuff like this? You can't really use these methods in the same way. Some of them have basic functionality for variation, like the default strip will strip off any white space and that kind of thing, but they're not really designed for this kind of advanced text processing. So this is where you probably want to reach for regular expressions. So the entire regular expression syntax is already outside the scope of this short talk, but these are the basics, which is what you end up using most of the time. So you can just type a literal character, like if you type A, that means A. A dot stands for any individual character. By default, anything except a new line, but you can fix that. You can have a set of characters or a range of characters between square brackets, and that's still a single character, but it's anything of what you've specified inside. There are also various shortcuts for character classes, which usually start with slash, which are a different way of saying this. So, for example, /d is any digit. There are also character classes for white space, not white space. There's one for word boundary. There are various, yeah, if you're writing like proper regular expressions in your code, you should really look into the character classes because they do things like smart handling of Unicode. If you use like the A to Z range, I think that's literally the A to Z ASCII range. If someone has an accent in their name and you're using that, you're going to have a problem. But in these slides, I've generally used the explicit character class, like the explicit character range, just because it's clearer to see. But in your own code, you should probably use the ones with slashes. So then there are various characters which modify the character immediately before. So this is how you say how many of some character you want to match. So question mark means previous character 0 1 times. Star is 0 more times, plus is 1 or more times, and then you can specify like a specific number. And also important are parentheses, round parentheses, which you use to capture parts of the pattern so that you can do some stuff with it later. The regular expression, well, the re module in the standard library is the standard module for doing regex in Python. So there are some common used functions for match and search. Sub is for search and replace, find all is for finding all instances, and split is for splitting. There's also a couple of other functions which are more obscure, which are left to the interested reader. in general, you specify regular expressions as strings, but you can use raw strings in Python to avoid escaping backslashes if you're using lots of those backslash character classes, so you don't have like leaning toothpick syndrome. But I think in most cases, I'm just using normal strings here, because sometimes it doesn't matter. So match and search, this is what you use to find a substring in a bigger string. The difference between them is that search will find that string anywhere in your string, but match will search from the beginning, but you can still have some stuff at the end. And both of these functions will return a match object if it does match, and none if it doesn't match. And sometimes you just want to use this as a Boolean result, does this match or not? But sometimes you want more information about how it matches and some more data. So I hope you can all see this code. I think it's reasonably big. Yeah, so you can, as you can see, the match, I'll speak more about the match object now, but that contains essentially information about like what kind of match you have. So in this particular case, it would print just the string that matched, which would be cuttlefish. So a match object stores various kinds of information about the match and gives you some methods that you can use to access it. There's a whole bunch of them. They're very interesting, but the one that I'm going to talk about mainly is how to extract bits of your pattern that you've designated as like special. So in this case, we've put parentheses around like the bit before fish. We want to know what the bit before fish is. So once we have the match object, group with no parameters will just give us the entire matching string, which is also the same as group 0. The 0 group is like the entire matching pattern. And then in groups, we have a tuple, essentially, of all the different matching groups, which we would have if we had put parentheses around different things. And we can access group 1 to get the first of these. Find all is when you want to find all instances of a particular substring in a string. And if you just use it without any parentheses, it'll give you just a list of strings, which are like all the substrings that matched. If you do use parentheses, if there's only one group that you've specified, you still just get a list of strings with that one group. But if you've specified multiple groups in your search pattern, you're going to get a list of tuples, which broken up into those groups. So for example, in the last example, we want to know what numbers are, and we want to know what the letters are, and we can break it up like that. By default, expressions like dot star will match the longest possible pattern. In general, regular expressions are greedy, so if it'll go for like the longest thing that it can possibly match if there are multiple overlapping things that could match. So people usually encounter this for the first time when they're trying to match things between, for example, quotation marks, and they have multiple sets of quotation marks on the line, and if they just put dot star, it'll happily match everything from the first quotation mark to the last quotation mark, which is usually not what you want. So if you put a question mark after your star, that'll make it non-greedy, so it'll match the shortest possible pattern, and in this case, it'll find the 3 separate instances correctly. Substitution, there's a search and replace. This allows you to replace a pattern with a string. You can put special values in your replacement string, which are called back references, which can refer to the things that you've marked out with groups in your previous string. So for example, you could use this to reorder certain things in your original string, if you kind of designate certain parts and then you just swap them around in your output. So in this example, we're just replacing anything you love with cats, but you want to preserve the initial part, which is I love, and then you want to preserve whatever is at the end of the line, which in this case is punctuation, like an exclamation mark. So we've designated those two things, and then we put them back in the substitution string, where I've used a raw string, so that the backslashes are just backslashes. The really cool thing about regular expressions in Python, which I think is possibly the single coolest thing if you've come from another language or something like SED, is that instead of a substitution string or a replacement string, you can use a function. And this function has to take a match object as its input and has to output the string, which is going to be the replacement string. And inside that function, you can do whatever you want, which is great. So you can have, this is the sort of thing people usually use this for. Like if you have something that you can't really easily do just in a regular expression. Like if you want to capitalize things, or you want to detect what case something is to start with and then do different things and do like, I mean, you can do anything in here. So for example, this just cleans up caps and makes whatever you pass to it have an initial capital and then all lowercase letters. And inside, you can just use normal string functions for that because that's what they're for. And split allows you to split a string within consistent delimiters, and it returns a list of strings, which are the split strings, and if you want to keep the delimiters or parts of the delimiters, you can put them in parentheses to capture them. So in this example, we have this horribly, horribly messy list, which uses spaces sometimes semicolons, sometimes commas, and like random numbers of spaces. And what we want to know is, was there a comma or a semicolon, and what was it, and what's the list? So here I've put the parentheses only around the comma or semicolon, and I discard the spaces because I don't care. And yeah, as you can see, it gives me both the delimiters in the bottom example and the split words. And in the first example, it's just the words themselves. There are various flags that you can use, which will modify how the default behavior works. So ignore case is, there are short versions of all of these flag names. I've just used the full names, but like they're also like, I think I, M, I think D, and then verbose is X or something. So ignore case lets the match be not case sensitive. So then you don't have to specify for everything, like the two possible cases, where sometimes you really don't care. Multiline, so I haven't discussed the caret and dollar characters, but they're the beginning and end of line characters, and by default, they apply to the entire string in Python. So even if you have new lines, it'll treat the entire string as a single line. But multiline essentially forces the engine to treat each line separately. So you can do kind of line by line parsing, like you might do in something like sed. Dot all lets new lines be treated as a normal character. So it makes the dot stand for anything, including a new line, where by default it excludes the new line. So kind of dot normally only works within lines. And verbose is quite a cool thing, which lets you lay out long regular expressions cleanly. It lets you essentially expand the string onto multiple lines, and it ignores white space on the edges, essentially, and lets you put in comments, and also ignores the comments. So it can make a really ugly, gigantic regular expression look slightly less ugly if you go to the effort of kind of reformatting it. And there's a single flags parameter in all of the functions. It usually comes kind of towards the end, and there's a one parameter, but all the flags are bit masked, so you can combine them with or, well, with the pipe character. You can also compile regex objects. This is something you might want to do if you have the same regular expression and you're using it like a million times. You may as well compile it. There's like caching, which makes this not hugely important all the time, but there's no reason not to do it. All of the module level functions have equivalents on the actual regular expression object. Obviously, just the regular expression string parameter is discarded, and then the other parameters, I think, are always like in the same order. So how do you write a good regular expression? There is seldom a single correct answer to what regular expression do I use to match this thing, because there are many different regular expressions that could match it, going from a very general one like dot star to like super, super specific. And in general, you want to be specific enough that you only match what you want to match, but you don't want to be so specific that you're unnecessarily discarding valid options that you have no reason to discard. And this depends very much on your input, what your input is like, how regular is it, how well can you predict what your input is your input going to change in the future, is your input made by a person or is it output from another program. So for example, how do you match an email address? If your input is a list of names with email addresses in angle brackets, then you match an email address by just extracting everything from between angle brackets. You don't have to say anything else. You know it's going to be an email address. But if your input file is a whole body of text which has some email addresses swimming around in it, well, then maybe you want to say it's a word which has an @ sign in it. Maybe you want to be like a little more specific than that. You need to consider what the word boundaries are. Is there going to be punctuation at the end sometimes? You know, what do you want to exclude? People also sometimes use regular expressions to validate form input data. And somewhere on the internet, there's a very, very long, very ugly regular expression which allegedly validates the syntax of email addresses according to the official specification. I think it says on the web page, which gives you this regular expression, that you probably shouldn't use it, because if you want to test if an email address is a valid email address, you send something to it and see if it bounces. And if you have a service where people sign up and you send them a validation email, then you're going to do this anyway, so this is already pointless. But sometimes you want to check, did this person accidentally put an email address into the name field, and vice versa? Does it have an @ in it? If it doesn't have an @ you can say, are you sure that you've put in your email address correctly? But as I'm sure some of you have encountered previously, web forms that discard email addresses with a plus in the username, which are perfectly valid and totally work and are very useful like anti-spam tools, but some overzealous web developer has obviously put in a very clever regular expression which says that you're not allowed to have a plus in here, so it's not valid, which is very annoying. So it's possible to overdo this. Regarding input and future-proofing, what you're doing when you're using regular expressions is taking arbitrary text, which is unstructured, and you're extracting structure from it. And this is a somewhat dangerous and error-prone process, especially if this is text that comes from a user, and it may change in the future. So you should treat portions of code which do this kind of parsing with as much suspicion as like file I/O, and put in the requisite error checking, use a lot of tests just to make sure that you're not going to fall over if something slightly unexpected happens. It's pretty easy to check, obviously, if the regex doesn't match at all, because you're going to start using a none, like a match object, and it's going to complain. But it's much more difficult to tell if your regex is matching, but it shouldn't be, and you're getting garbage later on in your code, and you might only realize like sometime later. So use a lot of tests, and try to think about how your input might change in the future, and make sure that you're being a little bit future-proof. Some pitfalls in the use of regular expressions. I've seen some regular expressions that like literally take an entire page, like a whole monitor screen. If you're writing a regex and it is wrapped around your entire text editor 10 times, I think you've made some poor life choices that you should reconsider. But this sometimes happens for a good reason, or at least a not entirely stupid reason. Sometimes people work with frameworks that they haven't written themselves, and the framework has some kind of filter functionality, and there's a place where you can put in an arbitrary regular expression, but you're only allowed one at a time. So you have to cram everything into a single expression, which it gets a bit ugly. In general, if you're writing the code yourself, there's no reason to write super complicated repeating patterns with like repeating patterns inside repeating patterns, because you can start off by splitting up, the big thing, and then you take the little things and you write separate regular expressions to split them up, and you can write things in a nicer, more sensible way. And I've very seldom personally found the need to write a really long and really elaborate regular expression. Like 90% of the time, I use 10% of the syntax. If you absolutely have to write a long, gigantic, hideous thing like this, do please investigate using the verbose flag to make it look nicer so people can actually read it. Parsing XML with regex, don't do it. There are XML parsers. There are lots of them. You have like 10 to choose from or something. You can use regular expressions on the actual text that you get out of the parser at the end. But sometimes you have a bunch of HTML files and you just want to extract the titles, and you know that there's going to be title tag, a title, and a closing tag, and nothing weird is going to be in there. And it's really almost just like text. There's no reason not to just use regex. You can do it. You're allowed to, but just don't tell anyone, because they'll only be upset. And some references. The regular expression module documentation is pretty comprehensive. It does also have a good overview of the syntax, so it's kind of like your one-stop place for regular expressions in Python. And it's got pretty detailed examples and descriptions of all the functions, so I recommend that. There is also a new third-party library, which is, I think, intended as an eventual replacement of the remodule, which has like fancier handling of various kinds of Unicode stuff, and more options. There is more stuff in it. It looks very cool. I haven't really looked into it in detail, but if there's an option you're missing, then you might want to look at that. Regularexpressions.info is a massive page all about regular expressions, which isn't Python specific, but if you want to know syntax stuff, then you might want to check that out. And there are various kind of web sandboxes where you can test out regular expressions on the fly. And pytex.org is one of them. There's like a whole bunch of other ones. So yeah, if you just want to play around and see, test out your regular expressions in a more kind of nice interactive way, then I want to check that out. And that is the end of my talk.
Thank you very much, Adriana. I'm sure there's some questions. Yes, right in the front. Thanks.
Sorry to be such a question pig. If you're from a Unix environment, and as you mentioned, it's kind of second nature with sed, awk, grep, to know regular expressions. For someone coming from a Windows environment who's a bit noobish and not really astute when it comes to programming, it can be a little bit terrifying and intimidating. What would your advice be in terms of getting over the hump to the point where you actually feel confident putting regex into production code and using it, as a tool, useful tool that it is?
So my recommendation for just starting off and learning how it works is do go to one of the kind of online web page tools, because those are very nice to give you immediate feedback of what's happening when you try things. My other advice would be, when you're starting to write a regular expression, start with something very general, which will definitely match, and then break it up into portions. Like start off with like dot star for your entire line, and then say, okay, this thing, and then a space, and this other thing. Break it down like that. So start off with, don't try to do the whole thing at once. Start off with something very general, and then make things more and more specific until you're matching all the input you want to match and not matching things you don't want to match. So if you kind of break it down like that, it's a lot easier than trying to just like figure out the whole thing at once.
Cool. Do you have any more questions? Anyone? Anyone? Go. Oh, there you go.
There's a certain point where regular expressions are actually not complex enough, and you actually need a parser, and often not obvious what can be captured within a regular expression and what actually requires a parser. The classic case is where you have recursive constructs and you can't do that within a regular expression. But do you have any general advice on how you recognize those cases and what that means for people?
So I once knew more about the actual computer science theory of regular expressions and what isn't possible in them. I've forgotten all of that, but to the best of my knowledge, it's either impossible or difficult, even with the kind of added non-regular features, to match things like, for example, nested tags in HTML that are the same. Like if you have a bunch of nested divs and you're trying to use regex to parse them, you're going to have a bad time. If you're trying to parse any kind of language or markup, like before you start doing that with regular expressions, seriously look into whether someone's already done it and there's a parser, because this is a thing that there are parsers for. Anything that looks anything like a language, so HTML, but also any other kind of markup, even like relatively simple markup, partially because like if someone's already done this, there's no reason for you to reinvent the wheel. But if you're exploring completely unexplored territory and you find that you're putting in more and more nasty hacks into bigger and bigger and more complex regular expressions, at some point maybe you should stop and say, am I really using the right tool for this? I have sometimes written like partial parsers for like obscure wiki markups that I was like converting from one place to another, but like in many of those cases, this didn't have to survive past the end of my translation of my personal project, and then I could just forget that it existed. But certainly if you're making anything that you want to last, see if there's a parsing tool that's better that's already available.
Cool. Thank you very much, Adriana. Do we have more?
Someone
we do.
else
We do.
there.
Sorry.
What are the improvements that the third-party regex library provides, and is the API similar or not?
I haven't really looked into it very much. I kind of looked at the homepage very briefly while I was compiling the slide. But from what I understand, it does more extensive Unicode stuff because, of course, regular expressions were first invented before Unicode was a thing. So it was kind of like a bit tacked on. And there is some Unicode stuff in the built-in remodule, but not all of it is like, it's not very extensive, and this module aims to improve on it. And I think it just had like more features and stuff. But from what I can make out, the API is similar, but I haven't really looked at it in any great detail.
Cool. Any more questions? No. Okay. Thank you very much, Adriana.